Okay, algebra. We've done quadratic functions. We're going to do a little bit of modeling, which is a big fancy word for some word problems with quadratics. What we want to discuss, there are several things that involve quadratic equations. One of the most common is something that's called a projectile motion. So basically, you have a ball or some object, you throw it up and it will come down, okay? So that's the model, and that follows a parabolic path. So all of these projectile motion problems use this equation. So h of t, the height of an object as a function of time in seconds, is negative 1/2 gt squared plus v0t and h0. v0 is just the constant. So if you think of this, this is standard form. This is it's like ax squared plus bx plus c. Okay, so the negative 1/2 g, that's the coefficient of my quadratic term. The b is the coefficient of my linear term, and the c is the constant. So in this one, h of t, that's the height, and this is in feet. T is the time in seconds, okay? G is the force of gravity. That's a constant, so that comes from physics. G is 32 feet per second. V0 is the initial velocity, H0 is the initial height. So if we think about the initial velocity, if the object is initially moving up, so that is I take an object and I throw it up, so if I throw it up this way, that is a positive velocity. If I take an object and I throw it down or thrust it down, that is a negative velocity. If I have something like a car or a bike, let's just say I can draw a bike better than a car, or you might argue, and it just goes off a cliff, like if it just rolls off, this one, the velocity is 0. Okay, so if I thrust something upward, positive velocity. Thrust downward, negative velocity. Rolls off the bottom of a cliff or falls off a table, that's a 0 velocity. A diver jumps off a high platform at an initial velocity of 16 feet per second. What quadratic function represents the height? Use the vertical motion model to write this, okay? So it's going to be h of t. If it's always in feet, it's going to be negative 16t squared, because our formula is negative 1/2 gt squared, and g is 32. So negative 16t squared. The initial velocity is 16 feet, so plus 16t, and the initial height right here is 30 feet. So there's my function. So h of t equals negative 16t squared plus 16t plus 30. Okay. When would the dive, so if I want to figure out the initial height, when t is 0, I get h is 30. Okay, that's how I get that to be the initial height. When will the diver be at the maximum height? So this is just code for maximum height is at the vertex. So it's go find the vertex. If I'm in standard form, I know that the vertex is going to be t equals what, negative b over 2a. So that's going to be negative 16 over 2 times negative 16, which is going to be, what is that, 1/2. So at 1/2 second, I am at my maximum height. So that's telling me this is the x value of the vertex. If you know the x value, how do you find the y value? All you have to do is just plug that in. So h of 1/2 is going to be what, negative 16, 1/2 squared plus 16, 1/2 plus 30. So that's going to be a 1/4. So negative 16 over 4, this is negative 4 plus 8 plus 30, which is going to be 34 feet. So that is the maximum height. So if you look at it, I mean, obviously I started at 30 feet. I know that my maximum height has to be a number higher than 30. So it looks like at 1/2 second, which is right here, 1/2 second, I am at, what did I say, 34 feet. Okay. A projectile is fired vertically upward from a height of 600 feet above the ground with an initial velocity of 803 feet per second. Write the quadratic model for this. Okay, so it's h of t equals negative 1/2 gt squared plus the initial velocity plus the initial height. So in this one, since I'm talking about feet, g is always 32. The initial velocity they told me was 803 feet per second, and the initial height was 600 feet. So if I draw a scenario of what's going on here, so if I label this 1, 2, 3, 4, 5, 6, so this is 600, that's where this object starts, okay? So basically this object is going to go up and then it's going to come down and it's going to hit the ground. So that's what's going to happen here. So my formula is going to be h of t equals minus 16 t squared plus what, 803 t plus 600. Okay. What is the maximum height? Well, the maximum height, they're asking me for the y value of the vertex. Well, I really can't find the y value of the vertex until I find the x value. Okay, so if I do t, it's going to be what, negative b over 2a. So that is going to be negative 803 over 2 times negative 16. So if I do that on my calculator, 803 divided by, what is that, 32, 25.093. So it's going to be 25.093 seconds before I reach my maximum height. So what is the maximum height? I'll just need to plug that in. So that's going to be h of 25.093 is going to be negative 16. 25.093 squared plus 803. What was it? 803. Yep, 803 times 25.093 plus 600. So if I do this on my calculator, 25.093 squared, multiply that times negative 16, and then plus 803 times 25.093, and then plus 600. So I end up with 10,675.14 feet. So that is my maximum height. What is the height, approximate height in 50.9 seconds? That's going to be h at 50.09, or 50.9, sorry, 50.9, which is going to be negative 16, 50.9 squared, plus 803, 50.9, plus 600. So let's try that. So 50.9 squared times negative 16 plus 803 times 50.9 plus 600. So I get that the height is about 19.74 feet. What is the height after 1 minute? So that's going to be what, 60 seconds? So h of 60 is going to be negative 16, 60 squared plus 803 times 60 plus 600. So if I do that, 60 squared times negative 16 plus 803 times 60, and then plus 600. So I get negative 8820. Okay. So it says the height of the ball that I threw is negative 8820. That's not possible because the height of this thing should be, the minimum is going to be 0. So after 1 minute, it's going to be 0 feet. Okay. So again, when you get a negative number there, it doesn't make sense physically in this problem because this thing is landing on the ground at that time. What is the height after 3 minutes? Well, you shouldn't have to do any work on that. The height after 3 minutes is going to be 0 because it's still on the ground after the 1 minute. Okay. Let's look at this one. The height of a basketball shot, h of t, is given by this equation. The height of the basketball given by this equation, t is the time in seconds, h is the height in feet. Assume the rim of the basket is 10 feet tall. Okay. The initial height of the basketball, with the initial height, is right there. It is 6 feet. Okay. So 6 feet. The initial velocity, I can read that straight from the equation right there. It's 27 feet per second. 27 feet per second. What's the height after 1 second? So h of 1 is going to be negative 16 times 1 squared plus 27 times 1 plus, what is it, 6. So this is negative 16 plus 27 plus 6. So this is 17 feet. So after 1 second, the ball is at 17 feet. So it started at 6 feet, it made it up to 17 feet in that one. How long until the ball hits the basket? Okay, when the ball hits the basket. So this one, I'm going to go into Desmos and just look at this. So if I look at this real quick, we'll clear this guy out. So negative 16, t squared. Let's just do x. So since it's set up, x squared plus 27x plus 6, okay? And so I know that the basket is what, 10 feet tall, so y equals 10 is right there, okay? So if you think about it, I started out at 6 feet, so it started out at 6 feet, it's gonna go up, this one goes up to about 17 feet, it's gonna be in the basket, not the first time it hits 10. So if you look at this picture, if the guy is 6 feet tall right here, if this is 6 feet, it's going to hit 10 feet on the way up and 10 feet on the way down. So what I'm looking for here is right over here. What is that spot where it hits 10 right here? So that's about 1.52 seconds. So 1.52 seconds. What is the height of the ball after 12 seconds? So here all you're doing is h of 12, okay? So h of 12 is going to be what, negative 16, 12 squared, plus 27 times 12, plus 6. I think you know that if you put a basketball up, I think you know what's going to happen at 12 seconds. I think it's going to be on the ground. Just to verify here, so you're going to have what, negative 16 times 144 plus 27 times 12 plus 6. So at negative 1974 feet. So that means that it's really going to be at 0 feet. Ball will be on the ground after 12 seconds. Okay. So it's just this one projectile motion that we're doing over and over, and this is leads you up into the homework for doing other problems like this. Okay.